Greetings, my name is Togias and I will present you the paper with title Operator Training Using Simulation and VR Technology, a work carried out from Panagiotis Karagiannis, Theodoros Togias, George Michalos and Sotiris Makris. A brief summary of this presentation follows. First, the main reasons that led us to this study will be introduced. Then, the approach followed will be discussed. At the implementation section, a technical description of the implemented applications will be presented. And finally, the conclusion and the future steps of this study will be mentioned. In today's environment, manufacturing industries aim strategically at reducing training time and cost. As engineers require specific period to plan and introduce the training material to the operators. With the introduction of Industry 4.0 and its smart system that evolve rapidly, and also considering the shift of the industry from mass production to mass customization, it is observed that the manufacturing systems constantly change. For this reason, the operators should be easily and effectively trained to adapt in this new era using innovative tools to facilitate this action. Simulation is a model typically implemented through computer software that simulates the operation of a system. This model receives a set of decision variables as input, such as the design of the system that is to be simulated, the workload that needs to undertake, and the operational policy that needs to follow to perform this workload. The result of this model that is provided as an output could be any kind of information, depending on what is investigated or how it is used for. For example, some performance measures could be production rate, work in progress, or tardiness. Applications in which simulation can be used are numerous, especially in manufacturing. What this study focuses on is the use of simulation for training purposes. Virtual reality is a technology that allows humans to visualize, handle, and interact with complex PC data in an intuitive way. The benefits of using VR applications are multiple and change depending on the use case. In general, virtual reality is considered to be one of the most immersive technologies ever built, giving a realistic feeling to the user. Among the digital interfaces, it offers the most intuitive interaction with the digital world, minimizing cognitive load of learning a new particular digital interface that does not have such a realistic feeling. Application in which virtual reality can be used in manufacturing is mainly in the maintenance sector, where the maintenance operators need to be guided remotely by their supervisors. Additionally, training for manufacturing operations can be benefited from the use of VR applications, as well as other manufacturing processes such as welding. The last benefit can help all types of users get trained by interacting with virtual objects, validating new technologies, learn how to control remotely and safety systems. To summarize, simulation and VR technologies have been selected for training purposes due to the high immersiveness, attractiveness, and outcome they offer compared to traditional training methods. As explained in the introduction, this paper aims to describe how digital technologies can be used to train operators in a safe environment, learn to control virtual resources, and perform specific operations before he or she, the operator, work with the real parts. The two main digital tools that are used and this paper focuses upon are the simulation and virtual reality technology. A combination of these tools can be used for training purposes in order to increase the impact of the course, minimize the cost and risk for the operators. Based on the figure that is presented, the simulation is used to replicate the real environment, including all the resources that will be used by the operator, such as robotic manipulators, cameras or safety system, while the virtual reality application is used from the operator to perceive the environment through the simulated sensors and react to it through the VR interfaces. Regarding the implementation of the previous described concept, two applications have been developed, namely simulation and virtual reality application. Both applications have been created in Unity 3D game engine, in which the digital worlds can be set up and built, while several custom CIRPe scripts have been developed. The mentioned scripts also support a TCP/IP connection between the two applications that the user can set up from a custom UI. Using a TCP/IP protocol, smooth data transferring will be ensured between the two applications. These custom scripts enable all application functionalities such as navigation of the robot, individual access control, or control of the various systems such as the cameras. Regarding the hardware that should be used for each of the applications, for simplicity reasons, a Windows PC and an Android-based device such as smartphone or some smart glasses should be used. The PC is needed to run the simulation environment, while the Android-based device is needed for the VR application. As described before, in order to effectively run both applications and take full advantage of the demo, both devices, namely the Windows PC and Android-based device, should be connected on the same network. This requirement is needed to be able to establish the TCP/IP connection. The simulation application has the role of the server, initiating the connection socket, while the virtual reality application has the role of the client that is connected to the server. Getting into more details for the implementation of these applications, starting with the simulation environment, the mobile robot is emulated by a red box, while the arm is emulated by a white extension on the top of the robot. The operator can move freely anywhere in the corridors of the infrastructure by selecting a destination point, and then the navigation algorithm will calculate the best path for the robot to follow and reach it. This setup enables the operator to remotely control resources such as the mobile platform and the robotic arm with the camera. Moving on, the implementation of the second application, namely VR application, will be described. The user would be able to see the field of view of the camera mounted at the robot. As the robot or the camera moves around, the virtual reality application view is automatically updated in real time. This course has been applied on a use case streaming from the logistic domain. As a reference site has been used an old warehouse that contains pillar, metal pipes and corridors in which the mobile platform can freely move around and navigate in the space. The operators will be trained on how to control remotely resources like mobile robots in a safe environment, such as that of a simulation one, while at the same time they can use the VR technology to see the environment through the virtual camera attached at the virtual robot. In this paper, Two digital applications, namely a simulation and a virtual reality application, have been described as a potential method to train new operators. The benefits of using such digital tools have been also elaborated, focusing mainly on the safety of working on a simulated environment, combined at the same time with the intuitiveness that offered by an immersive technology such as of virtual reality. The next steps would be to evaluate the developed application from multiple perspectives. More especially, the initial action is to use the aforementioned application to train operators, evaluating their performance and learning curve. Additionally, a cost analysis would be made to identify the benefits for the companies from a financial point of view. From a technical point of view, an enhancement will be made to the existing applications, taking in consideration the aforementioned analysis. More specifically, more virtual environments will be introduced in which the operators can navigate and perform other operations such as picking of parts or assembling different other parts with the robot. Additionally, more complex resources can be introduced, such as mobile robots with one or multiple arms, increasing the level of complexity for more experienced operators. The research was supported from the European project RIMA, Robots for Infrastructure Inspection and Maintenance. Thank you for your attention.